Good morning students. In this lecture we will discuss about the jet propulsion cycle. As discussed in the previous classes, we discussed briefly on gas turbines, the Breton efficiency, the methods to improve the thermal efficiency of gas turbine, and in this lecture we will start with the the jet propulsion, the basic principles of turbojet and turbopropeller, and the next topics. So let us start. Uh, in jet propulsion, the principle of jet propulsion is obtained from the applications of Newton's law of motion, right? The concept of thrust. Now, when a fluid is accelerated, a force is applied on it. Now, from the Newton's law of motion, we know that a equal and opposite force is applied. Equal and opposite force is applied on it because of the Newton's third law of reaction. This opposing force is a reaction force, and that is the thrust, right? And for jet propulsion, any type of fluids can be used, but mainly two types of fluids are useful. First one is the highly compressed air admixed with liquid droplets, and second one is to use the oxygen separately as a oxidizer to be mixed with the fuel and produce a jet of gas that is mainly used in the rocket propulsion, which we will discuss later. So in the process, so based on the type of fluids, the jet propulsion engines can be classified in two groups, that is the air breathing engines where the oxygen is taken from the air, and another one is a rocket engine where the oxygen is carried within the system. In rockets, that is in oxidizer, the liquid oxygen is carried, right? So in air breathing engines can further be classified into reciprocating, it is the spelling mistake, it will be reciprocating propeller engines, and second one is the gas turbine engines. Gas turbines are particularly suited for aircraft propulsion because they are light, compact, and have a high power to weight ratio. Aircraft gas turbines operate on an air cycle known as jet propulsion cycle, and the gas turbine engines can be classified into mainly five types, that is ramjet, pulse jet, turbojet, turboprop, and turbofan. In your syllabus we will discuss shortly about the ramjet, turbojet, and turboprop engines. In the sequence given here, only the working principles are, as discussed, will be covered of ramjet, turbojet, and turboprop, and taken in the above order, they provide propulsive jets of increasing mass flow and decreasing jet velocity. That is, for ramjet we get the maximum jet velocity, and for turbofan we get the minimum jet velocity, right? Turboprop engines are suitable for lower cruising speed at low altitude, and ramjet can be used for the highest cruising speed at the highest altitude, right? Now let us start about turbojet engine. This is Heinkel HE178. It was the first aircraft in the world to be flown on the turbojet engine in the year 1939. It was developed in Germany during the World War II. Another two famous aircrafts which flew on the turbojet engine was the Concorde aircraft, and another one is the Soviet designed MiG-25. It was also used extensively in the Indian Air Force and retired a few years back. Now let us start with the turbojet engine, right? So this is the basic components of turbojet engine, and the TS diagram is shown over here. In the turbojet engine, the high velocity air first flows through a diffuser where it is decelerated, increasing its pressure. This is the diffuser part, right? Air is then compressed in the compressor. This is the compressor. it is mixed with fuel in the combustion chamber where the mixture is burnt at constant pressure. There is a burner section, and then the high pressure, high temperature combustion gas partially expand in the turbine, producing enough power to drive the compressor and any auxiliary equipment. This is the turbine part, and the exhaust gas drives the turbine, and on the same shaft of the turbine the compressor is mounted. So when turbine rotates, it also drives the compressor. So the driving power required for the compressor is taken from the turbine itself, right? Finally, the gas expands in the nozzle to the ambient pressure and leaves the aircraft at high velocity. This is the nozzle part. So in ideal case, the turbine work is assumed to be equal to the compressor work. The processes in the diffuser, compressor, turbine and nozzle are assumed to be reversible and adiabatic, right? This is the turbine expansion line 4 to 5. 5 to 6 is the nozzle. 6 to 1 there is the heat rejection. This as is the open cycle. If it is open cycle, this part will be missing. It is simply thrown out of the atmosphere. 1 to 2 is the diffuser, 2 to 3 is the compressor, and 3 to 4 in the fuel chamber, right? And another interesting part of turbojet engine is the afterburner, which is used over here. The afterburner is used mainly in the military aircraft, right? Space and weight limitations prohibit the use of regenerator and intercoolers on aircraft engines. The counterpart of reheating is afterburning. The air-fuel ratio in the jet engine is so high that the turbine exhaust gas are sufficiently rich in oxygen to support the combustion of more fuel in the afterburner. That is, after the turbine, more fuel is sprayed in the afterburner, and because of the enriched oxygen even at the turbine exhaust, the combustion takes place, and the burning of fuel raises the temperature of the gas before it expands in the nozzle. That is, afterburner is placed before the nozzle and after the turbine, right? This increases the kinetic energy change in the nozzle and consequently increasing the thrust. In air standard case, the combustion is replaced by constant pressure heat addition. Okay. So the applications of jet engine, turbojet engine, it is used in supersonic aircrafts. As turbojets have poor efficiency at low vehicle speed, this issue limits their usefulness in vehicles other than aircraft. Turbojets are still common in medium range cruise missiles due to their high exhaust speed, small frontal area and relative simplicity. They are also still used on some supersonic fighters such as MiG-25. Now for turboprop, that is a short form of turbo propeller engine, the features. It is known fact that the high thrust per unit mass flow of fuel can be obtained by increasing the mass flow rate of air, and this is obtained by using the propeller. Here the turbine is used to drive the propeller, and which in turn generates the most propulsive thrust. The thrust produced due to the jet action in this case is quite small, and the thrust is mainly obtained from the propeller. In the same like that the previous one, the diffuser, then the compressor, then fuel is added, then it is expanded in the nozzle, and the turbine work obtained from the turbine is utilized by some gearing mechanism to drive the propeller, and the propeller, depending on the propeller speed and diameter of the propeller blade, the thrust is obtained, and the rest part of the exhaust is passed through the nozzle, but the thrust obtained from the nozzle part is much smaller than the thrust obtained from the propeller in case of turboprop engine. Advantages are mainly low speed applications, they are important. These are the advantages. In low speed applications they are very efficient, but disadvantage, their high speeds, there are very some problem due to high shocks. It requires a reduction gear for the propeller, which increases the cost, and it consumes certain amount of energy developed by the turbine in addition to require more space. These are some examples, and mainly it is used in transport aircrafts. The next parts of the topic will be discussed in the next lecture. Thank you.